For creating the user, you have to import this to some code studio and have to go to this contrib and then Terraform and then AWS directory. This is something where I have this code written, which is actually from the release of Kubespray. Okay. I have modified this code for lots of resources because I was willing to create a 3-tier architecture. So there are lots of modifications done. I have already published this to the GitHub. Anyone can use it. It's already public. So here we have this credential-infrastructure.tf. In this, I have used a model from the specific release of Kubespray. If I go through this each of the lines, then it is having the Terraform block, which is saying you that you will be requiring a Terraform version of this Terraform version in your local where you are going to run the Terraform command. So this is important thing and required thing. Another thing is you will be needing Ansible version with a specific version number that I have already mentioned in the steps. I will be showing that. And then it is having provider, which is going to tell the user that, okay, or Terraform is going to tell Terraform that, okay, we are going to deploy the complete infrastructure in AWS. It can be GCP, Azure. In your case, if you are willing to deploy the same in respective environment. Then it is having availability zone block. Data block is something which picks the resources from existing already created resource. So if there's already created resource, data block simply picks that from there. And I have used a module here. I will go to the module directory as well. So a module path is /module/vpc. That is one directory which is parallel to the AWS directory. And here inside AWS, one directory up. So I mean the same folder and inside the same file parallel to the same Terraform file, manifest file, there's a module and the VPC. So this VPC is, I have this in modular format because it's going to be very healthy, or you can say you can easily handle it to import in your system or reuse the code actually. So it's good for reusability. That's why I made it modular. So in the main.tf file, this is the something important file for creation of the VPC. So you can check the Terraform documentation how to create the resource if you're going to create a VPC. So for VPC, _VPC is the resource, and you can give any name to create the VPC. And here is the required parameters by the standard documentation that will be required. So this is something we used to do manually. In this time is asking those input directly from here. So the same way it's creating EIP, internet gateway, and subnet. It's going to be the public subnet. It's going to create net gateway, and then everything inside this is already defined parameters in as per the standard Terraform documentation, and it is looking for input so that it can connect to the VPC or create that net gateway inside that VPC likewise. So this is just same way. If you create a net gateway, for example, from AWS console, so it will ask lots of input values. So this is the same way it is passing those input values from here using some variable values. Again, it's going to create AWS subnet, one private subnet, and backend private subnet. This is going to be this third layer, backend layer, and route table, and will associate in route table in a specific VPC, and will associate that route table again with route table association. So it's going to create 3 route table, as you can see: public, Kubernetes private, and then backend private. And here it's going to create the routing table association rule, so it can create this is the same concept that we usually follow in the AWS console to create the resources. But it is easy to use from this Terraform because it's modular and it can be used anywhere. So the code is reusable. Fine. The only thing we need to do is, so let me come out from module. The same way it is having another module, network load balancer. It's creating the load balancer because load balancer is required here to create to balance the load, because we are creating Kubernetes cluster as well. So the Kubernetes cluster, whenever it will receive the request from the front end, it will load balance to this specific node. Here and here are IAM rules. It is having lots of IAM rules for configuration of the master and worker node, IAM policies, lots of the related stuffs, instance profile, lots of things. So let me come out from the module repository. And there's one sample inventory, you can say template folder as well. So this template folder is actually used when we have created a Kubernetes cluster. Okay, first we will be creating 3-tier architecture, which will be creating multiple master and worker inside one private subnet. So once those are created, somewhere to create Kubernetes cluster, we will be needing to have those list of IPs so that we can make that a Kubernetes cluster. One master, one worker, or multiple master, multiple worker. So anyhow, it will need a host file. So this template file is something which is actually a template host file, inventory file, which is required by Ansible. And these values are going to be filled once the 3-tier architecture is created with multiple master worker nodes, and the Kubernetes configuration part will come later. So first we are going to create the 3-tier architecture. It will be having the names of instance as master or worker. It will not be actually master worker, not Kubernetes cluster, but the names would be there, and there would be security groups implemented respectively. And then after that, we will be creating it a Kubernetes cluster by configuring some required repositories or manifest or lots of binaries by installing in master and worker nodes. So for that reason, we will be requiring Ansible, and Ansible will be needing a host file. So this inventory folder, simply a template folder, is going to create a template host file from this inventory.tpl file. This is something a variable file we can, whose value will be replaced after creation of the architecture. Okay, jump back. So I discussed about create infrastructure. This is the main thing, and then output.tf file. Output.tf file is something which is having these lots of variables out as output written. So why this is required is the output block in Terraform simply tells that if there is already created resource from another manifest, maybe from create dash infrastructure, whatever resources we have created from create dash infrastructure.tf file, those variables value it will keep in these different variable names. So from created infrastructure, it is going to save those values in these variables simply because somewhere these values will be required when we are going to provision the Kubernetes cluster going further. Fine. And then we have so these were the important file. Ansible create as infrastructure. I will show you this credential.tfr files also, and then there's one variable.tfr, because we have made these all the fields available as variables. So all the input required to create the VPC, subnet, node balancer, etc, we are going to provide that from a variable file, which should be defined. So I can even directly write name here of that cluster that I'm going to. So when we create manually VPC, it asks, okay, what is the VPC name that you want to give? What is the VPC sub CID range, availability zone, lots of stuff it asks. So instead of providing it manually here, written it here directly, I have just used a simply variable.tfr where these variables are defined. So this is this file. So these variables are defined here. So, and the values I will be using. So in Kubernetes, there's a terraform.tfr file who is simply having key and value. The key means the variable name and the value which we are looking to pass it. So if we are manually passing it value directly, then it is something like that. So we can directly write all the values here. But this file is terraform.tfr file is simply something which is having the values. Let me check the value. Okay, here. Fine. And these variables should be defined somewhere. So which is inside variable.tfr. Okay. We can have one single TFR file also, one manifest also from Kubernetes, but it is easy to have different names so that it easy to read. It is for another user. So if we see in variable.tfr, it is having only the variable defined and these data resources. So I will not go too deep in this code. For that we will discuss in some another class. I will record another video to how to create these modules, how to create this Terraform TFR files, what are the blocks there, what are the resources defined there, lots of stuff. Okay, so here we just had a look on this all the required Terraform TFR files. So now after you have created a user, you just need to go to the Terraform this repository, clone the code and go inside contrib Terraform AWS. There's a one file credential.tfr files and terraform.tfr files. Only those you just need to update based on your requirement. So let me talk about terraform.tfr file. So here I have the option to, I have made it modular to use if you are willing to create a single AG availability zone VPC, then it will be having two private subnet, one public subnet. So it is going to be created in this IP range of VPC. You can just change it based on your requirement. So this is uh, depending on the user's requirement. If you want to create the same cluster in three multi-AG, then you can just go and update, just unhashed it and comment it here. So you have to comment it as per your requirement. Again here, bastion host number you can give, like if you want multiple bastion host if it is a multi-AG, then you can update that configuration. If you want to choose EC2 instance of bastion host to have more higher configuration in terms of CPU or RAM, or network performance, then you can choose a higher version size, EC2 instance size that you can see from AWS console. Okay. Okay. So and then for master worker node, so if you want to you create a high availability cluster, so you can create multiple master node. So based on that you can input the values here. It will create in this case one master. If you want two master, you can just put 2, 3, whatever you value you want, and the configuration size of the master node. So since I just kept for bastion host a small size, because here what bastion host will be used for only to connect into the master server, nothing else. Or we can use to fire kubectl command from there. So based on need or requirement, we can update these values here. Here the same way we can update disk size. So it is EBS size of the EC2 instance. By default, it's not by default. It is if you here it is 10 GB for now. We can update the size likewise. If you want etcd server as well, so we can have a separate etcd server, like in Kubernetes. Etcd either is created as a pod or we can create a separate etcd server if it is a robust HA cluster or it's a too much used HA cluster that is required. So this requirement is based on the users, which can be updated. Okay, fine. So I think, yeah, here it is important. Inventory file path here is something which is telling that it is going to create a host file here after we run this Ansible job or file. Sorry, Terraform job. So another file here is this one, credentials.tfr. So this credential.tfr is something having the access key and private key required for by Terraform, so that Terraform may know that it is which cloud account or with which user you are going to provision the resources. So we have defined here, we want to provision the default region as US West 2, the key name that we just created, as I talked, that was the first step, and the access keys. These are CLI keys. Okay, so once this is updated, you just need to save the code. Let me get back, and then after you save the code, make sure you have so the important thing is, after you created user, just update the credential.tfr files and terraform.tfr files, and entries you have to choose in the terraform.tfr files according to your role need. So go back to these steps I have defined in the steps.md file. The same thing I have mentioned, you have to having installation of the Terraform, this specific version, because it's version constant, and export these variables for if you, even if you avoid it to export, it will pick from the credential.tfr files. So but we will, it depends on users. If they if we do not define these variables value here in credentials.tfr files, it will be prompted in the terminal when we will run terraform apply command. So the next step is to clone this stuff code, and then update the credentials.tfr files, terraform.tfr files, and go to this directory AWS, and then run terraform init. And let me run Terraform init. So I'm here in this step. Sorry, I just run CD. So let me run documents and the DevOps world. Let me find the path. Self project and self project. And then Terraform. Get 3 tier to display, and then arc. Okay, I was here. So from here, this is the root directory of the code, and then you have to go from there, contrib Terraform AWS, and run Terraform init. Once you run, again come back, document steps, and then run. This command is simply applying the Terraform file with variable file. If you avoid this, then it will be prompted in the terminal. So I just mentioned the variable file path here only. Okay. So before we proceed to, it will prompt for yes, before we proceed to enter yes, you have to make sure is what are the resources going to create. Is going to create one resource inventory, file template inventories for creating a host file, because it will be required to by the Ansible to create a Kubernetes cluster from the existing EC2 instances, and those many resources very well. And then one is bastion host EC2 instances, only one, because I have chosen only one configurations in my terraform.tfr file, and this is going to be instance resource capacity configuration, and these are the default parameters that appears. So this was I was talking about. So when a resource is created, it exports, it displays lots of variables value here. So if we want to use some, for example, password underscore data, then you have to define output variable in the output.tf file, or even the same file. So this is something use of output resource in Kubernetes, in Terraform. So when you want to export the variable value in some specific variable for already created, which are going to be provision or provisioned value, then you can use from the output. So from the output resource, we have already defined some values, so it will fetch those and keep in one variable list, and then we can use it in next subsequent task. In the same way, it's going to create master, only one master, because I have chosen only one master in variable file, and then one worker with the detail, this one, and the name we can change again also in the variability of our files. And then this policy, load balance and target group, and inventory resource, cube master, instance profile, IAM roles, those stuffs. And for control node, these many, it will create kube worker, control node, and these many IAM roles, because this is going to be used when we are going to create the Kubernetes cluster inside it. So network load balancer, listener, those one, the one which were designed inside the module, or what are defined inside the Terraform manifest simply. So I think this is good. This is going to get VPC, etc, etc. We just review, which is instances, load balancer, subnet, lots of stuff. So it's going to create 31 resources. Out of that, lots of EC2 instances, one VPC, and 3 EC2 instances, basically version, master, worker, and one VPC, and then 3 subnets, one public, 2 private, and then IAM policies, and IAM roles, inventories, that way. So I'm going to press yes. Now this creation is going to take some time. So let's be here for the time being. Is going to create the resource. I will pause the recording for the meantime. Okay, here we go. So the code has, after providing yes as input, it has created those resources. So after it has created resources, it has created this output as well, because we have defined output.tf files. So this is nice for now. In the next step, let's verify these resources before we proceed further to create Kubernetes cluster. So I'm in a bonus, I'm going to provide you one very good stuff, like here. Let's check here. IAM, oh sorry, EC2 instances. Here, so you see here we have created, okay, you have to change region to US West 2, because we have selected US West 2 as a region. Let me plug in the chargers. Okay, so if you see, it has created these resources: bastion, host, worker, master, and other resources which are defined in the Terraform manifest. There's one logic, one method we can directly see these all Kubernetes resources or AWS resources, sorry, in one architecture diagram. So there's a one API, hava.io website, from where you just need to create a free account, and you just need to pass a IAM role created there, and it will populate your resources there. So let me log in. here with my account. So I just log into this Harvard.io. This is a bonus thing I am going to teach you. And add resources. When you click on add resources, click on auto. Auto will redirect you to the AWS console to create a role. Provide that role here. Once role is created, this role is required by this Harvard.io so that it can talk to AWS account. So once this is imported, click on import. I have already done this since, so I'm not going to do it again. It will create this kind of architecture from the existing AWS resources that you have created. So this is a very good step. You don't need to create this architecture manually, as it takes a lot of time. So whatever thing we have done is, let me make it more wide. We have the option features to make it more wide. And okay, like that. And then for each resources, so we have provision on one internet gateway, one VPC, inside that one load balancer. So we can get the information, you can get every information for each of the resources that you have just provisioned from the Terraform in this API. This is just a very important thing. I think it is very good features application or web page. So here we can see DNS name. This is important if we are going to use it. It has created in the load balancer. So then hosted tone, this name, lots of stuff, tags. And if you want to know more about this bastion host, which has created the bastion host with this configuration, the IP of the bastion host is this one. And in the free tier account, you can just create few resources only, but it's $60 per month for the basic plan. So you can choose this platform according to your need. Okay, so this is something very good thing. From one portal only, you can see all the Kubernetes resources, but in diagram, in architecture diagram. So we have seen this bastion host, net gateway. It's the net gateway IP is having public, and then this master worker, lots of things, and then one private subnet here. So this is one public subnet here, and then this is one private subnet, and again a private subnet. Private subnet is not having anything. I have just provisioned it just to show you, because this is 3-tier architecture. 3 layers are there. So in the one front layer is going to be the bastion host in this case, but in another case we can deploy any front-end application, or if it is required in actual company industries, we can use API gateway or ingress or services exporting method to use API and in the front end, or used to be used by user in the front end. And in the private subnet, we are having just EC2 instances or master worker configuration. In the last private, we will be having database. We have not provisioned database. We will be creating it manually and we will be attaching it. So in this class, our objective was to create these resources, the 3-tier architecture only. But the next step is to create this Kubernetes cluster. For now, the job has done only created the EC2 instances with this configuration and with this name. Internally, these are not configured as a Kubernetes cluster. To make it Kubernetes cluster, we will be needing to apply Ansible playbook or Ansible command, so that it will get the host file that is already created from the inventory template, and that inventory host file is going to be used by Ansible, so that we can use those EC2 instances to create a Kubernetes cluster. So now go into steps again. The next step is to create to run these commands so that you can connect to the the instance can talk, or you can set up before running Ansible and manifest. I have this key name downloaded when I created SSH key pair. So I have to run this sequence of steps so that my key is added to this place, and I am able to run the Ansible playbook command very easily. Because when Ansible playbook is running, it is something like this. Let me try to explain you. It is something like Ansible is agentless. There are lots of questions in Ansible itself as well. So agentless means we have my system here. This is my system. From there, I'm trying to connect all the servers. There are lots of servers that I connect from my system. EC2 servers, 1, 2, 3, 4, lots of servers we can connect. This is the benefit of Ansible, like from our own location, from our remote location, work location, we can connect to many servers. But for that, what it need host file Ansible. Ansible is agentless because we are the one directly able to run to the connect to each servers. We can pull data from those servers, we can push data, we can do any operations, we can fire any command from one script to all the server at one time. We don't need to log into. Earlier what used to happen is we have to go to each server for maintenance or update purpose, or for running some specific command or some binary update etc. But now we can just do one thing. We can run either manifest Ansible file or Ansible role, or we can just run a single Ansible ad hoc command as well, so that it is directly run. It can be directly run to the each servers in one go. But for that, it would need host file. Host file is having all the entries of all the servers. It can be having entries directly by IP, by host name, or we can categorize those IP entry in a specific grouping. So we can say like this is one worker. So one worker will be worker will be having a list of workers. And then master will be having a list of master, like that. So the host file simply is having anyhow the entry of DNS names and the IP name, or IP would work also. So once this is having host file, then again we have an Ansible manifest file, Ansible manifest. So this is, or you can say Ansible role. Ansible YML file is going to be used here. In this case, will be using cluster.yml and roles for that. So we will be using to run the configuration command of Kubernetes cluster in each steps in each server using the host. So for that reason, this host should be connected to this EC2 instance, because when we are going to run Ansible command, we are not going to pass SSH key in that command line directly, or we are not going to input credentials of each of these. So the better way is these all servers have just one unique key. We can just save the key in our .ssh and add that. So with that method, via the public key, we are able to connect to the e-servers. That's why we have these steps here written, and I added this remote in all these servers, so that with this key we are able to connect to those servers. Now easy steps is, if we have escape to run this escape, this command will surely fail. So now I will directly run Ansible playbook. Let's take a look on this command. Ansible playbook -i for input. We are inputting this host path, which is kept in the same directory, AWS, inside AWS inventory and host. So let's take a look. Inventory, inside AWS, there's a directory, inventory, and then host. So this file is already populated or updated with the entries of you can say the remote EC2 instances that are created for now, with the public specific IP. Okay, so and then in this subsequent command is going to use as cluster.yml. Cluster.yml, let's take a look. It's having all the steps that we are going to use to configure the Kubernetes cluster. So simply updating, checking Ansible version, compatibility, and bastion host configuration, etc configuration. This is a method to write Ansible role. So it is this cluster.yml file somewhere is using another required files also, like Ansible dot underscore version.yml here. If you see this, um, is checking the version from import playbook from another file, YML file, release.group underscore group file is also there. So that way it we can, with the standard way to write this role or manifest for Ansible, but we are not going to deep in dive check this for now. We can take a look on this or keep or write a Ansible manifest from scratch as well whenever it is required. Let me know in the comment section. For now, we are just going to use it. So all the steps defined here to write the to create a Kubernetes cluster in existing created architecture, this Ansible manifest is going to be used. Here somewhere you see a role is going to be used here. So there's a role folder already here inside um, like this bundle. So group bars here, all these all resources have variable value defined, inventories having just inventories like that. Okay, so let's move forward. There's a role folder as well. Let me take a look. Load in the parent directory, but so role folder is having all the roles which will be whenever a role keyword is called here, that means it's calling a role somewhere defined here. That means it is looking for this role directory from the same folder, and it is looking for that role that you have defined. So if you are looking for example, Kubespray default, and it is calling this Kubespray default, and it is executing all the tasks written here. The these tasks will be executed. So this is just templating or role concept of Ansible. This is a very important concept or as well, mostly asked in the interview. A very important concept and very used in industries to configure large configurations or working on clusters at one go. Okay. So here finally it's going to use Ansible underscore user Ubuntu, because once we log into the remote servers here, it is somewhere going to ask like which user you want to do that task with. So for example, if I'm going to simply run yum update, so after you log in here, so it's going to ask with which user you're going to run that yum update, etc like that. So here it is having that user, and then -b means become root. So it act like a sudo. Once you are going to run these manifest commands here in this server, it's going to say that okay, now behave like a root user, sudo user, and then run, and flushes the cache to avoid any memory leaking. I just run it. Okay, I just need to make sure I run it from the root directory, means from this three-tier architecture. Let me jump 3 step back and then run again this one. This command is seriously going to take approx 40 to 50 minutes. Let me take a note of time. It's 1:35 now. 1:35. Okay. It's going to take approx 40 minutes. I'm pausing the video. In the meantime, if you have any questions, just put me in the note or let me know in the comment section. I think the code is still running, so it's taking a lot of time. As I said, it's going to take approx 40 to 50 minutes. So as we started at approx 1:35, and it's going to be 4:14 that is 2. So it has already taken 40 minutes approx. So in the meantime, it's running. Let me show you the resources such as provision. I already showed you the Kubernetes EC2 instances, which were named as bastion, host, master, worker. And now here, this is the VPC. It has created. The first one is the default. If you remember, we have chosen this subnets, CIDR, and over this, it has created a subnet. So this is a new feature AWS has launched where we can see the real mapping. So the VPC is having these subnets. Private, first is public, and these two privates. And this is in one AG availability zone. Okay, and the routing table for each subnets. So if you see the routing table of public is connected to the internet gateway. This is internet gateway. And the private one is connected to the routing table of net gateway. And here's one more routing table which is still left blank. It is not connected. I think it is we will see it later on, but it's not a problem. And the third subnet, which is private subnet, is again having a route table which is connected to the net gateway. So this private is connected to the net gateway, the mapping you see, and this internet gateway is connected to the public one. And we can see here also the internet gateway created this one, and net gateway created this one. It is one public IP. Okay, this is what. In the meantime, the job is still running. So here we go. We have completed the execution of Ansible playbook command. Let me show you from beginning that we started. Let me scroll to the top. Okay, let me make it large. View. I don't see. We can see the view. Okay, let's keep moving here. So here we have started running Ansible playbook command from the root directory, and it was started at 1:35, and here it is 2:10. It has taken about 25 plus 10, 45 minutes, and it has now created the existing servers as Kubernetes server. Okay, this is good. It has executed all the steps which were required to provision the Kubernetes cluster. There are some failure as well, but we are not bothering about it because we should be able to connect to the Kubernetes cluster and we should be able to deploy any prod inside it. So we will check it further. So for now, let me take a quick recap. So far we have executed creation of the Terraform apply, Kubernetes 3-tier architecture and then Ansible playbook role. So it has created the 3-tier architecture as well as the Kubernetes cluster. Now let's follow the steps defined in these steps. .md file I have pasted here. So we have completed this. Now the next step is to log into manifest. The bastion host. So let's go here. Inventory. There's some inventory host. It has the host. Check on the terminal. Look at the host. I think this range. Okay. Fine. And now we will be connecting to this host. So this is the host file. and I think it's not updated one. Let me take a look on sample inventory. Anyways, so let's the next step is to connect to the bastion host. I'm going to follow the steps to connect to the bastion host. So I will be running, but from the root directory. So we are already in the root directory because we have executed Ansible playbook command. The bastion host has IP this one. So I will be running ssh-i, my key name, my person, and Ubuntu @ this one. Yes. Now we have connected to bastion host. Like I explained in this diagram here, we are connecting from outer world to the bastion host, which is in the public subnet. So we are here, we are connected to here. Now from here we will connecting to the again a private instance, which is a worker node, a master node. So let's go to the this one. But I have to copy that key here. So let me key.pm copy here. I will copy the key. Okay, and here we have the key updated. So I have to log into this master server from here. There's another method as well, but for now I'm using this key login method. So this key is too exported, like it is having too many permissions allowed for other users. So I will give the minimum, which is standard permission allowed for any key, SSH to now the master node. The node of okay here the master node is having IP, which is a private. So again, if you are able to see, we are connecting from bastion host, which is having IP 10.04.190 to the master host, which is having IP 10. Both are private IP, so it is easy to connect from public subnet based EC2 instance, which is bastion host, to the master node, which is in a private subnet, because it does not need a public IP that just demonstrated. So if you see, we are able to log into 10.0.159, which is a master. From here, let's need to follow further steps. It is saying sudo this one. So there's a file created after completion of Ansible playbook role, which is created inside /etc Kubernetes. We will copy this kubeconfig file. I will use this kubeconfig file to connect to the cluster. You can say in another terminal, in first terminal, I am still logged into the master from bastion host. In another terminal, I will open my kubeconfig in local and update it with my new kubeconfig file. But here, before we proceed further, you have to update here this IP as well. This IP is 127.0.0. That means it was the since we have copied the kubeconfig from master, so it was for master. That means master should be able to connect to the Kubernetes cluster itself, which is in the self node master. But in our case, we are connecting from remote location. That means we are connecting from remote my system to master node, which is in the private subnet. So for that, I have to update the DNS name of that. So we see we already have a DNS name here. We just need to go to load balancer. Here, this is the DNS name. So here you just copy the DNS name, and this is something we have to update here. And now we can simply run kubectl get or nodes command. First of all, let's see. Okay, it's not exporting. Kubeconfig, kubeconfig, maybe nodes. Something wrong. I think we copied something wrongly. Let me try again. Mm, Okay, we can copy, make sure we are having only one kube config inside this home kube, which is a standard default directory of kube config. Let's remove a cache from there. Cache and then export again kube config with the path. We don't need to do that, but for same purpose, we are just doing it. Once we have the kube config inside a standard kube config directory, then it Kubernetes or kubectl will automatically assume that it is having the kube config file. Okay, so you see, we are able to connect to the node. I'm in cluster. You can see there's a one master node, which is showing as roles control plane, which is the role that we see in IAM. It has created some roles and these things to create service account so that it can assign the instance so that it behaves like a master. Okay, this is a worker node, which is written as a non. The default pod we can the default pod we can see is running in the all namespace, are mostly in the kube system namespace. We can create here one namespace, kubectl create ns dev. We can see now namespace ns dev is created. We can provision a pod here also, kubectl get run using command line. There's a pod manifest method as well. Nginx kubectl run. Okay, I think let's just check this in the document here somewhere. We can create a pod image Nginx. Okay, I forgot to provide the name here. It will create an Nginx pod. We can create another testing pod. This one. This is sample pod I'm trying to show you so that you can understand how it's creating pod from command line, and it is actually working. The Kubernetes cluster is actually working the way we have. So we created two pod. One is in default namespace which is Nginx, and another one in the new namespace we just created, which is our network tool pod. You can create any pod of your desired choice for testing purpose. I will do one thing now. You see now these pods are listed here. The default namespace is having Nginx and network tool in this here. To test it further, the connectivity, you can just log in inside the pod. I mean, exit inside the pod. Before we do so, let's run pod -a -a to see the pod which node the pod is running. So we can see the dev one is having the IP. This is a pod IP, and it is running on this node, which is a worker node. 159 is a master node. As we see, we connected to the master node, and this in back to this terminal. And 78 is the worker node, and in worker node is having all the new pods assigned. So network tool is running in with the pod IP. This one, this is a private IP again. Now we will do one thing: exec inside the pod and try to run connectivity test. Kubectl it exec -it network tool network tool hyphen and there namespace, and then hyphen dash. Okay, so I'm inside the pod network tool, which is in the dev namespace. From there, let's try to ping Google or DNS. So you see, we are able to reach to the internet via this inside this pod, which is running in the worker node, which is 178. But if you remember, the worker node is already running in the private subnet, and that private subnet is exposed via net gateway. That means it should be able to it can reach internet. I mean, it can use internet inside it using net gateway. So let me try to ping google.com. Clear ping google.com. Okay, it's good. So as we see, it's quite well working fine. And let's exit from it. Pure Seattle get post again. Let's do this. Know the IP of another pod. We will try to ping to another pod now. Nginx from inside this pod network tool. So clear screen again. Inside, go back to this network tool pod again, and let's try to ping to the another pod. So we are able to reach. Since we are able to reach to our internet, we are able to reach to this another pod. So this is what we were trying to accomplish. So let's just summarize in a quick moment. So our task was to create a three-tier architecture and the Kubernetes cluster inside it. I demonstrated the same along with creation of a simple pod. It is able to reach to internet because of net allowed, and we have successfully created the pod and exec inside it. So this is what was the purpose of lecture. In the next video, I will be showing the most important part of this lecture, which is the second part. In that we will be discussing what is front end, what is back end. I mean, in terms of application. So we will be choosing a sample application, and we will deploy the sample application in this existing Kubernetes cluster. And we will show you how front end and application and back end is connected in Kubernetes. We can see this in normal EC2 instances when the code is deployed directly into the EC2 instances, not as Docker container, not as pod. That part we can see in separate lecture, but here in Kubernetes, how front end and back end is connected, it is important. So I will be showing in the next lecture, the second part of this video, how we can create a sample application. I will choose a sample application and will try to show you a front end of the same application, a back end of the same application with the code of the application and the database, and we'll try the connectivity. So I think this is for this lecture. I'm hoping if this is going to help you. Thank you for being here. Thank you for listening the video completely. And if I'm able to help you, just reach me at my email ID. I will be providing here in my steps here in the repo, as well as you can reach here for the blogs, whatever blogs are you are looking. This is my official supporting page. Here you can see reach me for any blogs. I have lots of blogs updated here. You can contact me with this docs.in, which is for DevOps website for cloud support, right? So I hope this is fine. So I will be sharing these steps along with the repo. Let me know if you have any questions in comment section. I will feel very happy to assist you for any kind of support, freelancing support, or kind of any document related stuff, or to teach you anything related to the cloud architect role, AWS role, DevOps roles, anything. Thank you. Bye for now.